Hello! So today we are going to go over Unit 2, Lesson 8. We're going to talk about the states of matter. Make sure that you are trying to answer the questions before we go on to the next page. So if you have to pause and try to answer it, make sure you do that before we go on. Alright, so what are the stages of matter? So we have solid, liquid, and gas. So your solid is not going to take the form of the container that it's in. Liquid is going to keep its same volume, but it's going to take up the shape of the container. And gas is going to end up filling the container. Alright, so see here we have our liquid. And that when it evaporates, it goes into a gas. And just the same, gas will condense and turn into a liquid. From our liquid, it can freeze and turn into a solid. Or our solids can then melt into liquid. And in some cases, your gas and your solids can actually go back and forth between each other. So some mountains high up in the high altitudes will actually turn snow straight into water vapor. Or if you ever seen like a mothball, those are solids that will actually give off a chemical and go straight to gas. It doesn't have a liquid form. So here is another view on that. You have your solid, which is going to keep its own shape. You have your liquid, which is going to take the shape of the container but not change its volume. And then over here you have your gas, which is going to fill up the container, and that's why we also have a plug on top to keep the gas particles in. So state of matter, which determines the state of matter for any material. So is it going to be the size of the atoms, how hard it is, the weight, or how the molecules behave? So while you're thinking about that, over here on the right, this here is going to show your temperature versus pressure, and how depending on what the pressure is and the temperature depends on if it's going to be a solid, liquid, or vapor gas. So which of these determines the state of any material? That is going to be how the molecule behaves. So the motion of the particles and the length of attraction between the particles. So it depends if they're positive or negative. So here we have our solid. They're all kind of bonded together. It's kind of stuck together. But when we add energy, they're going to go from a solid into that liquid state. If we add more energy, they're going to end up being a gas. So think of this as ice. This here is water. And this here would be water vapor. And this also could be steam if you want to look at it that way too. And just saying, if you start off with a gas and you cool it down or you remove some of the energy, it's going to condense into that liquid. And if you cool that down again, it's going to become a solid. So think of going from water vapor, it condenses into water. You can freeze it into a solid or an ice cube. So properties of a liquid. Which list describes the property of a liquid? So does a liquid have a fixed volume and a definite shape? Does it have a fixed volume and takes the shape of the container? Or does it always completely fill the container but it has a defined shape? Or does it always fill the container and takes the shape of the container? So a couple things we know about liquids is that it always takes the shape of the container that it's in. So we can get rid of this one. Because it has that defined shape. And we can get rid of the first one because it says it has defined shape. So now we need to remember and try to figure out that does a liquid always fill the container or does it have a fixed volume? So if we have a container and if we have 5 milliliters of water, we pour that into a container, is it just going to fill up to a certain point? Or is it automatically going to spread out and fill this container with that 5 milliliters of water? So water has a fixed value and it takes the shape of the container. So liquids. So why do liquids flow? It's because the particles are wet? Or because they're smooth? Is it because they're not in a fixed place? Or is that because they are attracted to each other? So liquids don't always have to be water wet. They can be a little drier, but they can still be kind of fluid. And not all particles are going to be nice, smooth, and round. Some of them might have, if you think of a water molecule, it's an oxygen that has 2 hydrogen molecules on it. And it's not necessarily going to be a nice round sphere. It's actually more, kind of think of like Mickey Mouse ears. So it's not always going to be smooth, so we can get rid of that one as well. And particles are not in a fixed place. So if you think of a container and you pour water into it, you have water, all filled with water, and then we're going to add sugar. And go some sugar particles. So as the sugar goes in here, you're going to notice that over time, even if you don't stir it, they're going to kind of dissolve and move around until you have that equal amount of sugar in that water. And that's because the molecules they can move. Okay, so they're not in a fixed place. So let's look at some properties of gas. So which of these are true when it comes to gas particles? They are free moving and combine with each other. They don't move at all. They move slowly and in a set pattern. They are in constant motion and always changing positions. So one thing we know about gas is that it does fill up whatever container you put it in, which means they have to move. So you can get rid of this one right away. And do gas particles, as they hit each other, do they become a larger particle? And as they hit another, they take up another? So eventually you're going to see one large molecule in the container? Nope. So they don't combine with each other. So you can get rid of that one because that part of the sentence is wrong. So now you have, do they move slowly and in a set pattern? Or they are always in constant motion and always changing position? We know that gas can always change positions because we have a container of gas in it. It might start up here at the top, and it might travel, hit the side here, come down here, and it can bounce all the way around and either gain or lose momentum as it bumps into things. So which one is true about gas particles? Is that they are in constant motion and always changing position. So let's go ahead and look at some properties of a solid. So how would you describe the behavior of particles in a solid? They don't move very much and do not change position. They crash into each other and bounce all over the place. They move very quickly and across large distances, or they never move at all. So if you look at a crystal, each one of these, they're just lined up next to each other until they fill up the whole space. I'll start from down. Are these still able to move? Yeah, there's going to be some slight wiggle room in between each of these, and that's why if you extend this into a cube, you can actually pass energy from this side through and out the other. So they do move, so it's not like they never move, so we can get rid of that one. And thinking that a salad, remember, salad doesn't take up the space in a container that it's put into, so you don't see them moving quickly and across large distances. And do you see them crashing into each other and bouncing all over the place? Remember, if we set this into a container, just set an ice cube in here, is it the particles going to start bouncing off the wall of the container and going everywhere? Nope. So we can get rid of this one. Okay. So that gives us that they don't move very much and they do not change position. So this one's still going to stay here. It's still going to move slightly, but it's still going to be in this location. And same thing for the one in this corner. Okay, so they move, but they don't move very much. And they do not change positions. Alright, if you have any questions, please make sure that you are sending me a K-mail so we can help answer all of that. And good luck on this assessment.